Welcome back to the channel. In this session, let us see the next example on projection of straight lines. The question is like this. The top view of the line 75 mm long measures 50 mm. The end P is 30 mm in front of VP and 15 mm above horizontal plane. The end Q is 15 mm in front of VP and above HP. Draw the projections of the line and find its true inclinations with HP and VP. Let us take the data towards the side of the paper first. There is a line 75 mm long which is measuring as 50 mm. So that means to say that, don't you think this 75 mm is the true length of our line? But in top view, this is measuring as 50 mm. It's just like example, there is a person who is of 5 feet. Suppose if the person is standing just beneath the lamp post, his shadow would be different. If he is moving away from the lamp post, the shadow would be increased in its length, or few occasions the shadow would be diminished. The same case, there is a line of 75 mm long. It is measuring as 50 mm in the top view. So 50 mm in the top view means this line representation would be PQ. This would be P dash Q1 dash and PQ2. The end P is 30 mm in front of VP and 15 mm above HP. The dimensions of the P is very clearly given. This is 30 mm in front of VP and 15 mm above HP. 30 mm in front of VP is nothing but below the XY line and 15 mm above HP above the XY line. Similarly, the point Q is 15 mm in front of VP and above HP. Above HP is given, but the distance is not given. So 15 mm in front of VP would come somewhere below the XY line, and above the HP indicates a position above the XY line. So keeping these things in the mind, what is that we are supposed to find out? First thing is, we should obtain the projections of the line and find its true inclinations with HP. So that is nothing but theta and the angle phi. Let us see the solution. I will be making use of grid sheet for the solution. So this is the grid sheet. The grid sheet clearly says that 1 unit is equal to 10 mm. Each block is 10 mm. First thing is, I will draw the XY line. With this XY line, I will call one end as X, the other end as Y, and let us mention it as VP and HP. So this VP HP indicates that projection of straight line is in the first quadrant. Now let us try to consider data by datas. What is the first data given in the question? That is nothing but 30 mm in front of VP. Take it below the XY line, and 15 mm above HP. Let us take it above the XY line. So I considered 15 mm. So from here to here it is 10 mm followed by half of the grid. You can see the graduations over there. So that is half, 15 mm and 30 mm. 30 mm is 3 grids. Let us draw one more line here, show the dimensions. Let us call this point as P dash, and this is the point P. Now don't you think we have got two endpoints? That is nothing but we have got two new locus. Draw a locus line representation. Locus line representation is an imaginary line, and thickness should be minimum thickness. I will update this line as locus line of point P in front view and the top view. We have considered these two data as of now. One more data is left out.
Point Q
is 15 mm in front of VP. That should be below the X line. Below the X line, 15 mm would be somewhere over here. So this would be the 15 mm. Let us draw one more locus here. This is 15 mm. Let us call this locus as locus of point Q in the top view. Where is the locus here? For the front view locus, as I told you initially, the data is not given. Left out is I want to consider these two data. By this time, I am very confirmed that the true length is 75 mm long and the apparent length in the top view is 50 mm. Fine. With these two datas, I will proceed. So before going for that one, I will let you know an important factor in projection of straight lines. Whenever I am having the true length has to be projected. The projected true length has to be rotated. Thereby, I am getting the apparent length. Keep this thing in the mind while solving any projection of straight line examples. Now, I am having a true length also. I am having apparent length as well. I will start from the top view data, that is 50 mm in the top view. Make use of your compass. Take 50 mm, 5 grids. Point P as the center. Let us cut an arc on the locus of point Q, something like this. Since this is the apparent length, let us increase the thickness of this line. Apparent length is ready. Rotate the apparent length, what we call the reverse engineering process. Project the apparent length, thereby I will be getting the true length. Simple concept. Now I should rotate the apparent length. P as the center, this point as the radius, I will rotate it like this. I mean, I'm coming downwards. I will go for the projection. This new point as the center, here, this point as the center, let us draw one vertical line. Do not know what is the distance. Why? Because we do not have locus here. So let us draw a line. I know if I'm doing like this, the next thing should be the true length. So what is the true length? Very clearly given in the question. The true length is 75 mm long. Measure 75 mm, that is 7.5 grids or 7.5 centimeters in your normal scale. P dash as the center, cut an arc on the projected line. There is no intersection here. Let us extend the projection line further so that it will intersect the arc what we have drawn. With this intersection, don't you think we are getting one more locus here? This is the locus of point Q in the front view. This distance is not given in the question. Hope it is clear. Now, let us join these two lines. And this is the true length. If this is the true length, this would be the true inclination. That is what we wanted to find out. This is the apparent length. Let me write it here. That should be represented as PQ. So this is PQ. And the true length should be P dash Q1 dash. I wanted to obtain PQ2 and the apparent length in the front view as well. I will follow this method. I know true length as well. True length I will go for projection. Projected true length I will go for rotation. Thereby I will be getting the apparent length. Make use of your compass. I know the value of true length is equal to 75 mm long, 7.5 centimeters in the normal scale. P as the center, cut it on the locus of point Q in the top view. Let us join these two with the help of a minimum thickness. So this true length, now true length, let us go for projection. Projection till where is the question? So I am starting the projection from locus of point Q. Stop it at the opposite locus. Q means stop it at a point P. And let us stop it at the opposite views. I am starting from the top view. Let us stop it at the front view. So this is the true length. True length has been projected. Now go for rotation. Make use of your compass. P dash as the center. Sometimes you can also use the word P prime as well. So P dash as the center, the new point as the radius. Now let us cut an arc. So this arc intersect the locus at this point. Now this should be the apparent length. Since it is apparent length, its thickness should be more. This would be Q dash. This is the apparent length in the top view. This is the true length in the top view. This would be Q2. Q2 when it is projected upward, that means when it moves to the front view, this becomes Q2 dash. This is also moving in the upward direction. This Q1 dash representation in the top view would be Q1. But what is the verification whether the solution is right or wrong? Please keep your scale at the end of the apparent length, that is Q1. If you keep the scale here, Q1 and Q2 should be on the same straight line. I have not changed anything. Now both are in the same straight line. If this condition holds good, it indicates that our solution is right. Let us conclude it. Within a box towards the right bottom corner of the sheet, go for the answers. So what is that they have asked you to find out here? Only thing is the true inclinations. That is nothing but theta and the angle phi. So this is the angle theta from the locus line to the true length line is the angle theta. From the locus line to the true length line. Next, from the locus line to the apparent length would be angle alpha. Locus line to the apparent length would be angle beta here. Let us make use of a protractor here one by one. What is the angle phi? Angle phi is close to 12 degrees. The space is too less, so I will write an arrow mark and show here. So this is equal to 12 degrees. Phi is equal to 12 degrees. What is the angle beta now? Beta is close to 17 degrees or 18 degrees. Let us see what is the angle theta. Theta and alpha are almost close to each other. We can see here just a variation of 2 degree or 2.5 degree. Let us place the protractor at a point P prime. Check out what is the value of angle theta. So theta is supposed to be 47 degrees or 48 degrees. Similarly, alpha, if you measure, that is 2 degrees greater than the true inclination. That is nothing but 50 degrees. The answers. Theta is equal to 48 degrees and the angle phi is equal to 12 degrees. So only these things we are supposed to find out as per the given question. But apart from that, just for information, already we have done this one, right? So what is that extra we can show here? We can show apparent inclinations. What I am writing in the pen absolutely not required in the examination. Why? Because only this is the part of our solution. So alpha we can give it. Alpha is equal to 50 degrees and the beta is equal to 18 degrees. Yes, we can also give this value as well. Apparent lengths. What is the distance of apparent lengths? That is P dash, Q dash, and that is P and Q. Let us measure the value of P dash and Q dash. How do we measure? Once again, make use of protractor first. Place protractor on P dash. And the 0 degree line should be in par with the apparent length line. Mark 90 degrees here. Similarly, place your protractor on Q dash. The 0 degree line should be in par with the apparent length line. Mark 90 degrees here. Now, just draw one line for 90 degree representation, 90 degree marking. Draw one more line here. Show the dimension as. So this is how we are supposed to show the dimension. Place your scale here. Check out the dimension. It is close to 7.4, 7.3 centimeters. That is nothing but 73 mm. P dash Q dash is equal to 73 mm. Similarly, what is PQ? Let us go towards the bottom of the sheet since we have got plenty of sheet available. P as the center and 0 degree in par with the apparent length. Mark 90 degrees here. Similarly, Q as the reference point. Place a protractor on the point Q. 0 degree should be on PQ. Mark this as 90 degrees. Draw one 90 degree line and draw one more 90 degree line. This is 50 mm. We need not measure this one. Why? Because this is the part of data, right? So this is 50 mm. And true length we need not find out. Why? Because it is already given in the data. Yes, we should show the distance. Make use of your protractor. Place your protractor on P dash. But now 0 degree line should be in par with the true length line. Let us mark P dash 90 degrees here. Q dash as the reference point. Mark one more 90 degree here. Draw one line. Similarly, this is true length, this is 75 mm. So other side true length we need not show it. Why? Because true length means it is same. Once for the last time, what is that one more thing you can find out from the solution? When it comes to the point Q, what is the distance above the horizontal plane is not known to us. Actually, it was not given. That distance now can be found out. So where is that distance actually? From the locus of Q to the XY line. So this distance can be found out. So time being, I will call it as X. So X is equal to 68 mm above the HP. But I will repeat, what I have written in the pencil is our solution. Hope you have understood. Hope you have enjoyed this video. Give this video a thumbs up and share with your friends. Don't forget to subscribe. Have a nice time. Thank you. Bye.